Hello. 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 Can you guys hear me?
Yes, sir.
Yeah, fine. Yeah. Okay. Hi. Let me introduce. This is Yogesh, and I have around 12, 13 years of experience in IT industry. Today, let's discuss about stack topic. And let's wait for a couple of minutes. Let's wait whether some more people will join up. So we'll start at maybe after 2 minutes. Okay, let's get started. Can you hear me? Can somebody confirm?
Yeah.
Yes, sir. We can hear you.
Yeah.
Yeah, I can hear you. Yeah, thank you.
Yeah. Thank you. Okay, let me introduce. This is Yogesh. Today, let's discuss about the first topic of stack and what is stack, what are the real-time application of stack, and then when we should use stack and things like that. Yeah, let's get started. I just share the screen. Is this visible?
Yes, sir.
Yeah, fine. Thanks. Before get started, do you guys have any idea of what exactly is stack? How does it work, and what are all the applications of stack? Just basic idea you have, or shall I get started with the basics? Fine.
Yes.
I'll get okay. What is stack?
Stack is like a data structure which has one open end, like through which insertion and deletion takes place.
Yeah. Just 1 second. I'm able to draw here for some reason. Just give me 2 minutes. Something is not working here. My device. Just let me correct that. Yeah, you guys can see my screen, right?
Yes.
Yeah. Yeah, stack is a data structure. Basically, it's a kind of it has a last in first out. We can insert and remove pop element from in a last in first out manner. Assume this is a stack. Whatever you insert, which say assume I have elements like 10, 20, 30. If I insert 10, it goes into the stack, and if I insert 20, it goes on top of the 10, and if I insert again 30, it goes above 20. This is how, I mean, we keep it is a kind of a stack of plates, you can assume. I am putting just one after the other, and a stack of books one after the other. Books I am putting. So, and when you remove whichever is at the topmost element, we pick that first, and then for the element which inserted first, which eventually it comes at the end. So stack is a data structure. Basically, we insert elements in a last in first out manner. And what are all the operations we can do in stack, right? See, one is basically we need to do push operation. This is the first basic. I need to push the elements into the stack. And the second one is pop. Pop means whatever the last inserted element which comes first. Just it checks whether the stack is empty. If stack is empty, pop is a kind of a no operation. We cannot remove any element, right? If stack has any elements in the stack, so we can remove one element which is present at the top of the stack. And we can have one more like top element, which is the element present at the topmost stack. For example, if I have 10, 20, and 30, 30 will be the top element. And then some there are some auxiliary functions we can write, like what is empty, whether the stack is empty or not, or whether the stack is full or not. See, these are all the basic stack operations we can do: push, pop, top, is empty, and then is full. Okay, see, this is by looking at the just definition of stack and what are all the operations we do in the stack, right? It looks like fairly simple, but the advantage and the applications of stack is enormous. Like if you in a programming in a computer world, right, the stack is used extensively as used in many of the applications. Like, say for example, you must be aware of recursion, right? Recursion means just you call a function, you call a function calls by itself. Like, I can just recursively call function in a function, the same function. So in that, what happens in the background is just basically for each function call, it keeps pushing into the stack, and whenever you come out of the function, so it just removes the func frame from the stack. That means it insert one after the other, whichever is the topmost element, just it removes out of the stack, and then it does some operation. See, and that is the in the computer extensively used in the programming also, day-to-day programming. And even if you do function calls, that is also all the parameters which pushed into the stack, and then whenever you return, it pops out of the stack. And and if you look at the web things, right, even in the browser also stack has been used extensively. Like, if you look at the web history, it stores, for example, if you check any browser, go to Chrome, Firefox, or any browser, and then go to the web history, you can see, right, like if you see the last 1 hour history, it shows what are all the web pages you accessed. It shows last recently used at the topmost, and then recently used at the down. Say for example, if I'm checking for 10 o'clock to 11 o'clock, maybe if you make some transactions, or when some access in the web, if I do 10:15, 10:45, and then 10:30, 10 o'clock, it shows this is at the top, and then this is at the next top, and this is the next, and so on. So that is how the implementation of that web history thing is also done using stack. And also, if you look at any text editor or any programming IDE, right? Say for example, I type something goes bad, I just do undo operation. That means what an undo operation does, whichever you inserted last element, last character or last word, it deletes first. That means whichever you inserted first, I'm deleting the if I do undo, the last inserted element we just gets removed. See, that is also implemented using stack. And there are a lot of problems actually if you a lot of mathematical problems also we can solve using stack. A lot of real world problems you can solve using stack. For example, if you look at any what do you call map applications like Ola, Uber, or whatever, right? They do for example, if I distance from place 1 to place 2, and all, if I find out all the paths, longest path, shortest path, whatever, to find that one, it basically gives out all the paths, right? So that also, that those are all actual problems as we can solve using some of the classic depth first or breadth first search mechanisms. But internally, if you use a DFS, you have to use stack as absolute structures, because stacks plays a major role while storing all the data. And also all the tree traversal, if you look at any tree traversal, right, traversal, it could be pre-order traversal, it could be post-order traversal. All the tree traversal, either you can do using recursion, that is one thing. If you use recursion also, internally it uses stack. And also manually, without using recursion, if you want to write in a non-iterative, non-recursion mode, then also you need to have a stack to store data to solve the problem efficiently. And there are some classic examples, right? How do we find out the talk span, and some classic examples we can solve using stack. And again, if I look at the programming things, right? If I do, if I say, for example, I'm doing some iterating some expression. Say, for example, I'm doing a plus b star c. Correct, right? This is called the infix expression. Infix expression means, see, these are all a, b, c are called operands, and then these are all the plus, star, slash, those are all called operators. This is a form of a infix expression, right? See, even if you open any calculator in the system, or if you if some sort of calculation like 10 star 20 plus 30, it doesn't immediately evaluate this expression. Basically, if I do this kind of evaluating the infix expression, the efficient way is how the computer does is it either converts it to infix expression, or it converts it to postfix expression, and then it does the evaluation of expressions. So how do we convert from infix to postfix or infix to prefix? Again, you have to use stack as auxiliary data structures. Or say, for example, just I'll give 10 star 20 30, right? See, if I convert it to postfix example, it will be like it will operand, and it will be 20, and it will be star, and then it will be 30, and then it will be plus. This is the equivalent postfix expression for this particular expression. See, how does it evaluate this expression? Again, in order to evaluate this expression, it uses stack as auxiliary data structures, and then it basically it evaluates the expression. Something like, it is operand one, and this is the, again, these are all the operands, and these are all the operators, right? So if there is an operand, I need to push into the stack. Say, assume I push 10 into the stack, and then 20 is also an operand. I just push into the stack, it goes 20, right? And the moment I hit the operator star, what I should do is, actually there is some noise. Can you please mute? I don't know from where it's coming. Yeah. And star, and in star there is it's operator, and at the moment we hit operator, we have to pop the last two previous elements from the stack, which is 20 and 10, and I can do math on this. 20 star 10 is equal to 200. I pop these elements and again push 200 back to the stack. So essentially 200 goes into the stack. Then 30, it is a operand, so I push 30 into the stack, it goes to the stack. And plus is an operator. Basically, then you pop last two elements and do math. So 200 plus 30 is equal to 230. This is how it evaluates the stack. This one we can take an example and then solve. Is it clear, at least at very high level, in where and all stack is being used?
It's clear. It's clear.
Yeah, it is. Thank you.
Yeah, thank you. So now let's now let's do one thing. Let's implement stack using Python, and then we'll solve this, and we'll solve a couple of 2 or 3 problems from basic to intermediate levels, or maybe one I'll take bit difficult problem also, and we'll discuss around the problems. Fine. First is, as I told, Any question? Okay. See, we need a stack, right? As I told, these are all the operations. One is push, one is pop, one is empty, one is full, and then the top. These are all the functions we have to implement. And yeah. There is some.
Can you mute everyone? I think two people are have not muted themselves.
Okay. Okay, I'm doing mute all. And if you have any questions, please post in chat, and then I'll unmute. Okay. Fine. Okay. These are all the operations we can perform in stack. These are all the top, push, pop, is empty, and is full. So let's implement stack using Python. Okay. Okay. First, I'll do class stack. This is my stack. Okay. And what I need to do, I need to have these many things. Is push, is empty, is full. But if you look at Python, Python provides a list, right? I'm planning to leverage the list data structure of Python to implement stack. So what I'll do is I'll create whenever somebody creates a stack class or stack object, just I'll have a empty list. Something I'll call it as items. Items is a list. That is what I'll do if somebody creates a stack. So that will be kind of I'll put it in a constructor method. I mean, it is not exactly constructor, but you can think it as a constructor. So just I'll do items is equal to this one. Just if somebody creates a stack class, I'm creating a Python list. Okay. And then what are the other functions I need to push, pop, is empty, is full, and top, right? So just I'll write the functions, just push. If I do push, what I need to have, right? Because I need to have the element to be pushed. That means I need to take the element as a parameter, right? So just the element I'm going to push into the stack. So I'll just do pass instruction. First, I'll write the prototype skeleton for the entire operations, and then I'll start writing the implementation. Then what is the next method? Pop doesn't really need any arguments, because pop is just I need to check this particular stack and then pop out the last element present in the stack. So just I need the self object, that's all. This pointer kind of thing. Just this is the path. This also I'm not going to implement now. Just I'll write the skeleton. So then is empty. It's a if the stack is empty, it's going to return true, or if it is going, or it's going to return false. And then is full. This also, if the stack full is we are handling dynamically, though let's not try to do stack is full, because if I want to do full, then I need to define here how many what is the capacity of the stack. Since we are we can handle large number of data, so let's leverage the Python stack. So we can assume it's we have enough, we can store a lot of entries. There is no full method. So these are all the main things: push, pop, is empty, and what is the top element which is present in the stack. What is the top? So this also just returns the topmost element in the stack. See, this is the skeleton of my stack or stack class. So let's try to implement and test side by side. So I'll just call if this is a standard, not required. Just this is the main, call main function f main. Just I'll run this just to see is there any errors. There are syntax error, invalid syntax. Where is invalid? Now there was an indentation problem. I just removed and corrected it. Say run it. There is no problem now. So now what I need to do, first I need to create a stack, right? I'll create as a my stack is the object. I'll instantiate my class. So now the moment I created a stack, what it does, it goes into the init function and then it creates a list, Python list. So assume I want to test with, I want to insert 10, 20, 30, 40 elements. And then if I insert, first 10 should go, then 20, 30 and 40. And if I pop, 40 should come and then 30 and then 20 and 10. Correct, right? So how do I insert? Here, what I'll do, self.items.push of element. Just I'm pushing this into the stack. So if you look at this, I created a stack object. I'll do my stack.push of 10 and then my stack.push of 20, then my stack.push of 30. I inserted 10, 20 and 30. Just I'll print okay, if I want to print all the elements, right, I can just have an auxiliary method like display, and here I can just print self.items. Just I'll run this. Sorry, there is some line 28. List as, sorry, it doesn't have push, it's basically append. Yeah, append, right? I'm appending an element into the list. There is no push default function in a list, Python list. It is as append. So I inserted 10, 20 and 30. Just I'll print the display all the elements present in the stack. Let's call this function. It is printing 10. First 10 is there and then 20 and then 30. But if I pop, 30 should come, right? So, and what is the top element? If I call top element, it should show 30. And if I call pop, it should pop 30 out of the stack. And if I call empty, if the stack is empty, it should return true, or else it should return false. So now let's implement pop. So now first thing is what I need to do is just I can do return self.items.pop. Python provides a pop operation. List provides a pop functionality which basically pops the last element from the stack. See, just if I do it now, I'll do my print my stack.pop. If you look at it, this display displays 10, 20 and 30, and if I call pop, it is printing the last inserted element, which is 30. Now let's call display function again. If you look at it, it is displaying only 10 and 20 because 30 has been removed from the stack. Now if I call the same pop method, and then 20 is the next element, next popped element, and if I call display, it is printing 10. Now if I keep calling pop, what happens? See, it printed 10, and then now stack is empty. Let's try to pop. Sorry, this is, now it gave a trace back, right? Because it is showing some index error. Pop is because we are trying to pop element from an empty stack. So which is that is why we interpret it is throwing error. So before popping, let's say if if self is empty equal to false, then only I'll call it, or else don't call this function. Some indentation problem looks like. Okay, there is a spelling mistake. Empty. That is okay. So now we have to implement is empty, right? What exactly is empty? If the stack is empty, return true. If stack is not empty, return false. So if self dot items equal to empty list, just do return true, else return false. I no need to write else here, because if it goes inside if condition, it just returns. It won't reach here. If it reaches here, means it has not entered the if condition. So I'm doing just return false. So now what is the top method should display the last inserted or last pointer to the topmost element, right? So it is exactly just what I need to do. Return self dot items last element I need to present. See, either I can do length of x or I can do just -1, because Python provides negative index also, right? If I do -1, it basically it points to the last element. If I do -2, it is the last but one. If I 0 means the first element. So since we want the last element, that means last index of the Python list. So I'm just putting -1. So these are all the methods we just implemented. Let's remove these things and let's test now. See, now if I print my stack.top, it should basically print 30. It is printing 30, but it is not popping, because if I call my stack.display, all the elements should be there. Just I'm getting the index, not index, my last inserted value. See, stack is intact. We have not removed anything. But if I call pop, it removes the last inserted element from the stack and also returns that particular value. See, then if I call print pop, it is none. Okay. My stack pop is empty equal to false. Okay. Int enter else system. It's entering else is empty equal to false. Why it is why it is showing is empty equal to true, right? Equal to empty list, it's true. Okay, let's try print my stack dot is empty. Is anything wrong in this function? It is returning false. So when I call is empty equal to false, I am calling print stack is not empty. Sorry, this is a function, right? I'm not calling as a function. That is the problem. It should be fine. Python, we have to be careful because it doesn't throw errors always. So when I'm calling this one, it is empty is false. Now I'll call my stack pop. There are two things. Sorry, 30, right? It is removed the last inserted element. And then I call my stack dot top. I'll print. This is again 20. Okay, top, which is 20. And 10, 20, and 30 are there. And if I do print my stack display, it is printing 10 and 20. This is no need to print the return value of that, just I need to call my stack 10 and 20. So this is the the sample stack we implemented with all push pop is empty top and display parameters. So, and if I keep popping now elements, earlier we got some trace back because it was Python interpreter was throwing an error if we try to pop an element from an empty stack, but now we are handling here by putting some guarding with some condition. So even if we do it, just it returns none. That's all. And if the elements are present, it basically inserts in the last in first out order. It removes because I inserted 10 first, 20 next, 30 and 40. While removing 40 came out first, 30 came out second, 20 then third, and 10 fourth. So, and also let's see, I now if I do this 10 and 20, right? Even if I do stack of push of some 999, it goes 10, 20, and 999 goes after 20. We can check that out. 10, 20, and 999. And again, if I pop, since 999 is last inserted, it comes out first. We can say desktop. See, this is the one which came up first. So, any question? Just I'll unmute and let me know if you have.
Bangalore में ही है.
Hello.
Better mute them, Yogesh.
Yeah. I think I have to mute selectively. All is not working. So it is not.
सीनियर कैटेगरी मैनेजर के अंदर हम उसको रिपोर्ट करता है सीधे सीधे.
But still I see some. Okay.
इस रिपोर्ट सीईओ को नहीं, ये रिपोर्ट करता है वाइस प्रेसिडेंट.
Oh man, why it is not okay? Any questions you can post in the chat if you have.
Yeah, I have two questions. This is Samrat. So you did not implement the isFull function, and can we also not try to implement the length function on stack? Length function.
Okay, length means basically how many elements are present in the stack. That's you want. Okay.
Yeah, on the basis of that, say for example, first we define a length function, and we assume that, or we define a value for that, length equal to 100. The moment the length reaches 100, and if we still want to push something in, then it should say that it is full.
Yeah, that's correct. Yeah, that I understand. Yeah, that also we can do.
We can implement that, right?
Yeah, we can implement. What you need to do is, say for example, while doing this one, what is the size of your stack, right? Capacity. Capacity you have to pass here, and then this is the capacity. Then each time when you, and then what I can do is I can have self dot some what is the number of elements present in the stack. Self dot, what is the right word? Okay, maybe the current length, or self dot index, whatever I'll say. Okay, is equal to, starting it will be 0, and then self dot capacity is equal to, I'll take as a capacity variable. So now while creating, let's create a with 10 only. Okay, just I run, and then my I print my stack capacity. See if you look at it, how much did I? Okay, I'll just comment all these out. Then yeah, we can try. Comment this. See 10. See if you look at this, 10 is the capacity, right? I'm printing the 10 also here.
Yeah.
So while in push element, if self dot index, okay, not less than self dot capacity, then you push, and then you do self dot index is equal to self dot index plus 1. Okay.
Yeah.
If it is else, what I need to do, you can just say print stack is full.
Yeah, you need to end. You need to end.
Yeah. Yes. Whenever I pop an element here, what I need to do before,
you did not end it with the colon.
Yeah. Yeah, now it's fine, right? And in the pop, if the element is false, what I'm doing, that this is basically I'm doing whether stack is empty or right, and then I'm popping the element. Before popping the element, what I need to do, its index is equal to decrement the index -1. And you want the how many elements are present in the stack, right? You can do def get what is the right name, length. I'll call length only, length of self. Then just do return self dot return length of self dot items. This should be fine, right? Say for example, I created a stack with capacity 10. I'll just call my stack dot and call print my stack dot length. See, this is capacity. First I'll print this capacity, and then what is the length? Current is 0, right? Now I'll do my stack dot what is push 100, and then after that I'll print length. The length is 1. Now I'll reduce the length to just 5. Now length is 1. Now I'll try to 5, right? So now I'll do 200, 300, 400, and 500. See, now the length is 5. But if I try to insert next one, it should error. It is indentation error. I got push of 999. See, stack is full. See, now if I do, it did not insert this particular element, but now if I do my stack dot pop, and then if I try to insert this, it should work, because I popped 500 and then I pushed 999. Let's print the stack. Print my stack dot display. It is printing 100, 200, 300, 400, 999. 500 it inserted in the middle and then it removed because we're doing pop operation, right?
Correct. Thank you so much. Thank you.
Yeah. Sir, why is there no empty parenthesis after capacity?
I couldn't tell you last words.
Okay.
Hello?
Hello, yes, sir.
Hello? Yeah, can you repeat the question? I couldn't get your question.
Yes, sir. Why didn't you put an empty parenthesis after capacity in the main function?
No, capacity is not a function here, right? It's just a variable. That is why.
Okay, sir.
Yeah, these are all the push, pop, isempty function. So I'm putting the opening and closing brackets wherever you can see. But capacity is just a variable which is present in the stack. These are all the variables, index, items, and capacity. Directly I'm printing. I'm not exposing a function to print this one. I can expose that also. Say for example, print capacity stack. We call stack capacity, then self. Then here I can call return self dot capacity. Now I can call capacity capacity. Now it is a function I have to call with open and closing brace. If it requires a parameters, I need to push some pass parameters. In case of push, it requires a parameters. That is why we are passing it. So now if I run, its output remains same. It is printing the capacity as 5.
Okay, sir. So, sir, what is the difference between length and capacity?
Length is, where is the length is, okay. See, capacity is whatever I'm restricting. Like say for example, my stack should be of length 5. Maximum the stack capacity is 5 elements. I can store only 5 elements. That is the capacity. Length means how many we stored. Say for example, if at this point in time, I'll comment this. Even though my stack capacity is 5, it is 5, correct, right? But how many elements are present in the stack? I pushed only one element, right?
Yes, yes.
1 minute. Capacity is this. Yeah, I'll comment all those things. Let's focus on these two lines. I created a stack with capacity 5 and I printed a capacity, it printed 5, correct, right?
Yes, yes.
Now I inserted only one element into the stack, which is 100. So now if I call length, it shows how many elements are present in the stack. That means only one, right? 100
Okay, yes,
is the
yes,
one.
yes.
So if I run this, it is showing only one element present in the stack.
Okay, okay, sir, got it.
Yeah, and if I do 100 with 200, which is say it is a length is 2. Basically, a stack has 2 elements. Okay, this is the basic implementation of stack. Anybody? Yeah.
Why we need to use that index separately? Instead, we can directly put the length of an element, which is dynamically get the length and then compare with the
Yeah,
same.
we can do that is also possible.
Because,
Just
that
on
will,
the fly, the moment I heard the question, right, that came to my mind, I implemented that way. Yes, we can definitely do that.
because unnecessary again one more operation we'll be doing on instant.
Yeah, I completely understand. This is not the completely optimized code. There is a room for optimization. Yes, you're right. Again, some noise. Any more questions? Okay. Okay, now let's discuss some problems. I hope the basic stack functionality is fine. Let's solve some problems using stack. By sometimes, by looking at the problem, we can easily tell we can solve this problem using stack. And sometimes, if you, okay, one problem I'll take, a bit tricky problem. I'll try to solve using first naive approach, and then I'll explain how we can, solve with the better complexity using stacks. And before jumping into the problem, just I want to go with some basic problems. Like, okay, let me explain this one. Okay, let's take an example. Like, okay, I say so if somebody asks, remove the adjacent duplicate elements given in a string. For example, say if I have area, okay, say these are all adjacent elements, right? Because I've taken these examples just because I want to explain what exactly is a in place stack. There is some concept called in place stack. Just I would like to demonstrate that, so I'm taking this problem. Then after that I'll take a couple of more interesting problems. Say for example, this is the given string, say given input string carrier. And the question here is, I would like to remove all the adjacent duplicate elements. If you look at it, E and E are the adjacent duplicate elements, right? So I have to remove this. After removing this, and R also become the adjacent duplicate elements. I have to remove these two. And then what should it print? It should basically print after that, it should print CA. And if I have CA, RE, or C, A here, and A will become adjacent. We have to remove these two. The problem is a bit tricky, but not difficult. See, correct, right? How can we solve these kind of problems? Because when somebody says, adjacent elements are, because that is what, right? I can push these element, and if I, before inserting the next element, if I compare the last inserted element, I'll get what is the element stored. If there are same, I can just correlate. Oh, okay, I can remove both of them. So since it is related to some adjacent problems which are sitting beside the character, beside any character, so you can usually think that we can solve using this stack. But first, okay, let's see how we can solve this problem, but just using separate stack, and then can we optimize that. Say if you look at it, this is the input string CAREER, and this is my stack, correct, right? And what I need to do, I need to parse the entire string, and then at the end I should print only CA, right? Because after removing REER, it will be, the output will be the CA. What I can do, see, this is the stack, right? Now the stack is empty. if the stack is empty, what I need to do, because there is no computation needs to be done, right? Because stack doesn't have any elements. So push the element if the stack is not empty. That is the first thing we can do. So what I do, I will push C into the stack. Now I'm parsing A, right? See, check, this is my index stack point top element, and this is my the element which currently I am parsing. Check whether the current element is same as the last inserted element which is present in the stack. Is it same? No. Then insert A into the stack. Correct, right? Now stack pointer points to A. Now R, just check R whether it's the same as the stack top. No, it is not same as the stack top. So what I need to do, I need to push R back into the stack. I pushed R into the stack. And remove this. Okay, now it comes at E, right? So E is same as R. No, E is not same as R. Just I'll come back. So now again E points at this point. So now whether E is same as E, yes, E is same as E. That means I need to delete this, right? I should not insert. And don't remove the element, because if there are multiple E's, if I remove this E also, we will not get the proper result which is expected. So just E is not same as E, E is same as E, just go to the next character. Whether R is same as E, no, R is not same as E, but E is E I need to remove, right? Because it was, we found a duplicate, just do pop. Stack pointers points at this one. Whether R is same as this one, yes, R is same as this one, then it goes out of the stack. Then since the previously compared element was R, I need to pop this. I get CA, and if I pop elements, it comes A and C. Again, I need to reverse, then I'll get CA. So if I take in another stack, what I'll do, I can do these things, but is it really necessary to use an auxiliary stack to do this one? If I get these elements as a list, like something like, because anyway string is constant in Python, you get an as a character array, array of elements, a list of elements, something like C, A, R, E, E, R. Then I can use this as only stack existing, because I don't care about deleting these elements here in the existing input only, right? I don't have to create one more stack object, push all the elements into the stack, and then pop all the elements from the stack, then do reverse and convert to list, and then convert to string and send it. Instead of doing that, since I can modify the existing input, I can think this only a stack, and I can do all those things. So let's discuss that. Okay. Say, let's say REER, correct, right? So what are some common conventions I would like to say? Say initial index, whenever I'm parsing, this is a zeroth indexing, right? 0, 1, 2, 3, and so on. So you can think, first my stack is empty. That means stack is not even having the 0th element. It doesn't have anything, right? So you can say stack top, some variable, I would say, which is -1. That means the stack is empty. So what we did in the while explaining by using another auxiliary stack, we can mimic the same. If the stack is empty, that means if the stack top is equal to -1, what we did push current element into the stack, correct, right? I call it as a ith element, push I. So how can I define here my stack is empty? That means if the stack top is equal to -1, it's just empty, right? So here just I'll write the pseudo code, and then we can convert it to code. If stack is empty, what did we do? Push I, current element, right? I. So then, since I'm not using our just created stack, the whatever with the push pop author operations, I'm trying to handle this only as a in-place stack. What insertion means? What I need to do? I need to increment the stack top is equal to +1. Stack top is is equal to stack top plus 1. Then it comes here. Then do this one, whatever the input array of stack top is equal to input of I. I am pushing C into the stack. Here the stack pointer is there. Anyway, elements are there, carry it, but assume they are not there. Just for the visualization purpose. Then here my stack pointer is top is there. I call it as top, and here my I is there. Whether both are same? Yes. No, they are not same. Then what I need to do? I need to push, right? What is push? Increment the stack pointer and then replace the value present in the I in the thing. Basically, I am replacing A with A here. Then I comes here. Stack point top is this guy, and then current element is this guy. Whether these are same? No, sorry, and they're not same. So what I need to do? I need to push R into the stack. Since it is an in-place stack, increment the stack pointer and then replace R with R. So now this is the top and this is the I. Whether these two are same? No, they are not same. Do the insertion operation. So here the top comes and here I. These are same, right? What I need to do? If stack is empty, R stack top and current element are not same. I'm doing push. Else, what I need to do? In while loop, okay, because if there are multiple is, just I need to retain this pointer, but I need to skip all these elements. I should not insert, right? So if this element is same as this element, just increment I. Again, I is same as I increment I. Correct, right? Now these two are not same. But E, we found out that we found a duplicate with E, right? I need to remove E also. So that means while all the iteration from 3 E's are done, and now here I is pointing to the R, so I need to essentially remove from this stack, right? So decrement the stack pointer. So top goes back to this. Now R and R same, correct, right? Now increment I goes here. Now R also I found a duplicate element. Now you do top is equal to top minus minus. I got now the string parsing, entire string parsing is done. Now I end up having only C and A. Correct, right? So what I need to do? I need to return value with C and A. Return. See, anyway, I have this pointer and I know the beginning of the index of the beginning of character. So if I know C and A, just I can do, since it is a list, I can do input of 0 : what I want up to this, or after I need to include this also. I can do top plus 1. I can return this one, this list. If you want to convert it to string, we can easily convert. Is this fine? Shall we go with the implementation, or shall I take one more example and explain?
Yeah, I think we can go with the code.
Yeah, fine. Okay, since we already implemented a stack, I'll not try to solve using the taking a separate stack. Since since I want to demonstrate the in-place stack, I will take the existing input only as a stack, input the list as a stack, and then I do push, pop, and all other stack operations. Then to demonstrate we can take some other example to use stack as auxiliary data structure. That's fine, right? So what I'll do, okay, fine. Underscore do adjacent yeah. I'll take this one, copy. So this is, I need to call him, define a method, right? Def remove underscore adjacent underscore do. So what is the, I need an input array, right? Or else I'll call it as input. Just I'll call it pass. And then see, input string is equal to carries, right? So I'll call remove adjacent duplicate of input string. So now if I'll just print the input, it is printing R. Since string is constant, we cannot do anything with the constant. We need to convert it to a list, right? So I'll take my enqueue is equal to inp dot split I can do. But since it is okay, we'll do one thing. For that one, let's we use some delimiter. You can assume there's now I have these things, right? Just I'm converting it to a list because this is the input carrier. So this is my list, right? So you can think space as a delimiter.
Sir, what is split?
Basically, since it is a string, I'm converting string to a list. So split basically splits the string with the delimiter as space. Or else if you're getting confused, we can do one thing. We can pass this as an input. Let's not worry about string and all. Just I'll take this as an array. Okay, and and I pass this as input one. This is not there. Okay, now this is my carrier. I need to remove adjacent duplicate elements. That is, these two are adjacent duplicate elements. After removing these two, R and R are adjacent duplicate elements. Recursively, I need to delete. These are also this one, and then remaining elements are CA. I need to return CA. Correct. So now I'll take top as an input parameter is equal to -1. And then I'll take index is equal to 0. I'll start from 0th index and I'll iterate all the way from 0 to the length of the array or list. So what I'll do is I need to traverse from 0 to the size of the list, right? While I is less than length of input. Just I'll print what I need to print inp of I. Just I'm printing all the characters. Sorry, it went into infinite loop because I did not increment. Sorry. I killed it. Okay, now I do I is equal to I plus 1. It printed all right, carrier. So now what I should do, now if the stack is empty, I need to insert, right? See, if top is equal to -1, stack is empty, or input of top not equal to input of I. Not increment here now. Let's do it here. Okay. That means if the stack is empty or the current element which I'm parsing and the top element present in the stack are not same. If they are not same, what I need to do? I need to do insert. So while inserting, just I'll do top is equal to top plus 1, and then this is I am taking my input array as top. Input of top is equal to input of I. Correct, right? So what I need to do, then I put this one. I need to, the current parsing is done. I'll just do I is equal to I plus 1. Else, that means if when when I'm processing C and A were different, so I incremented the stack pointer and inserted A into A. A is done. Then I incremented top. Now top stack pointer is here. Since I incremented I is here. Again, A and R not same. So stack pointer comes here, and then I'm currently iterating E. And then when stack pointer reaches here, that means when stack pointer is here and my current element is here, so they're same, right? What should say, assume I have one more E here. I should just increment this, and again S and E are same, just increment this. When S and E are not same, decrement this. So E is actually pointing to this. So again R and R same again. So let's focus on this part and then complete our implementation. Since we did it in a loop, right, till there is a match, I'm just incrementing it. That means while, and since I need to do it in a loop, I'm using while input of what is the top equal to input of I. If it is same, and if it goes beyond the size, we should stop it, or else the behavior might be undefined, right? So while I is equal to length of input and input of top equal to input of I, what I need to do, just I is equal to I plus 1.
Sir, can you
Okay.
explain the if loop, the content in if loop once again?
If condition, right?
Yeah.
I'll explain. Okay. See this one, right? See what I'm doing. If top is equal to minus 1 means currently I'm not inserted any element, right?
Yes.
So if that is the case, I need to insert. So what? So that means when I do top is equal to minus 1, the T index is somewhere here.
Yes.
Correct, no? We'll call it as something I. So non top. Okay. So when I want to insert, and then I is at this place.
Yes.
Since stack is empty, I'm trying to mimic that I'm inserting C into the stack. That means I'm just doing top is equal to top plus 1. So top came at this point, and I'm doing input of top is equal to input of I. Still I've not incremented the I. That means I and top both are pointing at this one. And now I'm inserting input of top is equal to input of I. C with C only.
Okay.
Then I incremented I. Correct, right? So top is at this point, I is at this point. Again, these two are not same. So again, insert into the stack. That essentially I'm incrementing the top comes here. I is still at this point. I'm inserting A of top is equal to A of I. Insertion is done. Then I increment I. I goes at this point.
Okay.
Again, they are not same. So insert. So top comes this point.
Yeah.
Again, I goes this point. Correct, right? So again, they're not same. I need to insert. Top comes here, and then I did the insertion. Then I need to move I.
Yeah.
So now here, this is the interesting point. Both are same. Correct, right? So I should not replace because my goal is to remove. Just increment I. I comes at this point.
Yes.
These are also same. My intention is to delete, right? Then increment I. I comes at here. So that means since they're not same here,
Increment
that means
the top.
no, E I need to delete, right? I need to decrement the top. So top comes at this point. Correct, right? Now again, if you look at R same. I need to delete this. So that means increment I. I goes out of the index, but top is at this point, right? That means if I reach else condition, your both current element and the top of the element are same. So I need to decrement this. So I come at the decrement this. So now entire my string parsing is done. What is the elements I have? Starting index anyway I know. Last index will be the top.
Yes.
These two, return these two.
Okay.
Correct, right? So after a while, what I need to do? I need to do top is equal to top minus 1. Correct, no?
Yeah, one question.
Yeah.
Yeah, on the if loop, we say that top equal to -1 and input of a top not equal to input of a. So input of a top where it goes for the last element, right? When we say input one of -1, as you said, last one always the last -1 goes to the last element.
Yeah.
So let's say if we have the last element as a C in our scenario,
Hmm.
it gets matched, right?
Can you tell the example?
Okay,
I
in
mean,
the sense, let's say in our input one, we have a CAREEE and then C.
C, right? Okay. See, if you look at this example you're taking, right? Then
Yeah.
output will be CAC.
CAC, exactly. But
Yeah.
in our scenario, in the if loop, when we say input of a top, this top is -1, right?
Yeah,
So,
top is now, yeah, no, okay, this is the tricky example. Okay, we can trace. Now top came here, I at this point, right? Because we have I now, because correct, right? What I'll do, A is equal to, these are all not same. That means I need to insert into the stack. What I'll do top is equal to top plus 1. I is till at this point. A of inp of top is equal to inp of I. That means I'll replace R with C here.
no. At the first insertion, I mean to say.
At the very first insertion.
He's
At the
talking
very
about the
first,
OR condition. He's talking about the OR condition. OR.
Yeah.
no. At the beginning, yeah, if condition.
Yeah, if
Okay.
OR, right? That OR part you're saying.
Yeah. If top equal to -1 or input of a top not equal to input of Y. First,
Yeah.
when
What is the problem with it? I mean, I'm not.
no, input of -1 will give me C again,
C.
right?
Yes.
And then input of I also will be.
No. Input, if it is -1, it will not even come here, right? This condition is satisfied, it goes inside.
Oh, okay.
Correct, right? Because in R, if one of the condition is successful, it will not execute the next one.
Yep. Yeah. That makes clear.
Yeah. So any, is it clear at this, till this point? Okay, I'll just comment this. Let's try to execute this carrier output. So now what we do, top -1, when it then top is at this point, right? So I need to print after coming out of while loop, print input of 0 till top. Just I'm printing it. Something, okay, this is I will remove unnecessary prints. There is one more print, sorry. Okay, it is printing CAC, no, which is wrong. Okay, let me carry C. This is CA should come, right? Because E3 is 2 thing. Okay, because I'm doing top is at this point, but if you do colon with this thing, it excludes the current element. 0 to 1 it prints. I need to do 0 and including 1. So I need to put top plus 1 here. Yeah, if I run this CA, it's correct, right? And then let's CA, I deleted this, and let's put A here. So output should be C, that is correct. Then if I put again C here, out should be empty because it all are adjacent duplicate elements I deleted. So I'll put D here. So output should be C and D because these three are adjacent duplicate elements I deleted, and after that RR is adjacent duplicate deleted, A and A are adjacent duplicate of the deleted, and CD is the output. CD is the output. So any other example you would like to try with? Or is it clear, or you want me to explain again? Just I wanted to explain how we can leverage the existing input as a stack and then work on it instead of recreating another stack and do push and pop operations.
So in 20 line, print in 0 and then colon top plus 1 is there.
Yeah.
So if you give top plus 2, then output will change, right? So
yeah, it definitely is.
So like instead of this, can we go for any other option?
No, basically my intention is.
So if we don't give anything, then also it will print till the end, right?
Yeah. If you don't give the end.
Yeah.
No, here basically my intention is to pick only these two elements, and I know where is top, but I want to include the current element. That is why I'm putting +1.
Yeah, understood. But if we by the time we have done all these operations, the last element of the list is A. C is the first one, A is the last one.
Yeah.
So if we don't give top +1, still it will print C and A, right?
No, it will print 3
No.
itself. You don't give top +1.
If you print entire array, you mean to say?
Yeah.
No, it will print entire array, right? Because we are still have the elements, but we replaced, we did some write operation on them. It's not the same input element, but we have the element.
Okay. The input array remains
same. That is what. See, if I just do all the elements are there, but I copied. It's not in the proper way.
Okay.
Because based on the logic, we just messed it up. Correct, right?
Okay, got it.
So now I need to pick only first two elements. I mean, from first to the wherever my top points. So that means I know from where I know where to end. But I need to include top element. So I'm putting this one. That's and again, if you want it to convert it to string, it's not a big deal. Just you can do join. It will convert it to string. Something like this. I mean, if somebody asks dot join of this, I guess. Sorry, something. What went wrong here? Okay, fine. I don't remember the syntax. Let's leave. Dot join of that should have worked. Okay, fine. I'll check it later. Any questions? Output is equal to dot join input of 0 to I should have done this of +1 and then print output cd if you want to convert it to this. Yeah, any doubts, any questions? If it is clear, I'll take one more example and maybe we can try solving that. Is it fine? Anyone? Yeah, fine, yeah. I'll move it to a bit, I don't call it difficult, just we'll try to solve this problem. Okay. It looked like some kind of real-time problem so that we can, decide and we can see whether we can solve using how we can solve this problem. See, you can read out to the problem. I'll just take 1 or 2 minutes and then after that I'll explain the problem. Okay, let me read out the problem. See, there are various towers present in the city. Towers are aligned in a straight horizontal line from left to right, and each tower transmits a signal in the right to left direction. Tower A shall block the signal of Tower B if Tower A present to the left of the Tower B and Tower A is taller than Tower B. So the range of this, okay, you don't get confused. I mean, just I'll take an example and tell 180, 60, 70, right? Okay, sorry. Okay, I'll clear this. Hundred 80, 60, 60, 70, 60, 70, 60, 75, 85. 85, right? So you can think of this. See, this is the height of the tower, right? 100, and this, and you can see this is 80, this is 100, this is 80, and this is 60, and then this is 70, and again this is 60, and then this is 75, and then here it is 85. 75 and 85. Correct, right? Since this is the leftmost tower, it won't traverse any signal left side. You can say there is a big wall here. Okay, so how many units you can traverse the signal? Only one, because from ear to ear you can traverse that side. Then 60, this 60 is not the 80 tower is again smaller than 100. It cannot bypass the signal, right? This tower will block the signal. So it also can traverse only one unit, that is the current unit. It cannot go beyond this. Only current unit it can go up to current unit. 60 also same thing, because the one that left hand tower 80 will block the signal here. So this cannot go behind this, right? This is also one. 70, what you can do, it starts from here, it comes here. 60 is smaller than 70. I can easily go, right? You can bypass. But 80 is the blocker. 80 will block it. So how many units it can traverse? This unit and this unit. Total 2.
2.
Correct, right? 60 again only the current unit, not beyond that. So 1. 75, it easily crosses this, and then easily crosses this, and then 80 is the blocker one. It will be somewhere here. Then this guy will block. So 1, 2, 3, 4. 4 units it will cross. 85, it easily crosses from from ear to ear, right? 100 is the blocker. That means 1, 2, 3, 4, 5, 6. What if I look at the expected output? 111, 2146. 111, 2146. This is what the problem. Is it clear? Problem statement?
Yes, sir.
Yeah. Now what we should return is, this is the input is the array or list, which all the unit signifies the height of the tower. The output should be whatever the output we got here. It should be 1, 1, 1. Okay, and one more array, I would say 1, 1, 1, 2, 1, 4, 6. This is an okay. This one, let's not directly jump into the stack concept. First, let's try to solve using whatever brute force approach, and then we'll try to figure out what is the time complexity, and then can we reduce the time complexity by using any better algorithm, and in order to use the better algorithm, can we leverage the stack? Let's see that. Okay, so now, okay, let's it is this. Okay, let's clear the page. 86. Okay. This is the input, right? 180, 60, 70, 60, 60, 70, 60, 75, 85. 85. See, if you look at it, and let's try. I'm trying to solve the problem using naive approach first. This is 80. This is, I'll put somewhere 60. this is 70, this is 60, this is 75, and this is somewhere 85. This is 100, 80, 60, 70, 60, 75, 85. So if at all, if I use naive approach, what I should do, I should calculate for this, calculate for this. In any way, we have to calculate for this cell, this cell, this cell, this cell, and so on. So that means I need to traverse from year to year anywhere, right? Because for every item, I need to find out a solution. So what I'll do for I in from range from from 0 to n, I'll traverse. But zeroth element, do we have to really find out? No, right? Because it is the leftmost element. It can traverse only one unit. So I'll take an output array with whatever the length I have got. So I'll put output of 0 is equal to 1. It cannot transmit more than 1 unit because this is left hand side. This is the blocker. There is no space in the left hand side. This is the leftmost element. Correct, right? So now I'll start from 1 to n, not 0 to n. So that means when I is pointing at this thing, so what I need to do, I need to traverse from this guy to this guy, 0th element. That means for j in, from where to where? From I to 0, I need to traverse. I to 0. Then here, if a of I, that means the current element is greater than or equal to a of j. If this element is bigger than this element, I can transmit the signal, right? So what I'll do, output of I is equal to output of I1. And then else, I don't say, for example, assume I'm working out, I'm starting from 70, I is at 70, then 60 is smaller element, and then I did O of I is equal to Y of I plus 1, J came at this, J was at year, and then anyway I passed year, J is 60 is again lesser than 70, I decremented J comes here. Now J is anyway bigger than 70, it's blocked the signal. So do we really have to find out for 100? No, right? Because nowhere I reach 100, because since it's blocked, I need to stop. No point in calculating for the cells which are sitting in the left hand side. Else, come out of the loop. So this loop I'll come out and then keep doing this. This is the basic the formula we are planning to do. So if we do this way, what is the time complexity? If I do this way, the time complexity for each element, I traverse the entire element, right? This is something like O of n square. O of n square is generally not accepted. So we should, reduce the time complexity to the better one. This brute force method is clear? Or shall we try with brute force first and then jump into stack to get better understanding? Hello?
We'll go the brute force first.
Yeah, fine. Yeah, sure. So cool. Okay, fine. Okay, for this one we already implemented the stack. Just I'll leverage this. I'll just take this class. Okay, because in previous example we used as a in-place stack, but here we are planning to use the separate stack. No error. And then these lines. Okay. Fine. Then I'll call this the signal range, right? Def signal underscore range underscore brute force. I'll call it. What is the input? I'll call it as input array. Pass, and I'll take input is equal to same examples. I'll take 100. Okay, here there is an example 100, 80, 60. 100, 60, 70, and 100. What is that? 80, 60, 80, 60, 70, 60, 75, 85. I'll call this function except some parameter we did not provide. So crypt, now it is fine, right? At least skeleton is fine. So now what I need to do here, right? I need to take the result array and just take result is equal. Okay. I need to have an empty array with pointing all the zeros, right? I'll take a result array for I in input, result dot append of 0. If I do print result, I'm just initializing all the values to 0, 0, 0, 0. This is, you can do in multiple ways. This is one thing. Or if you really want to do in a Pythonic way, Python, you can do result is equal to 0 or length of input. This is as good as doing this one. Or else you can do list comprehension also, something like whatever the way you want to do. Result is equal to something like this, 0 for I in length of input. This is also the same. Just I'm giving one thing can be done in many ways. That's all. Not sorry. Okay. 0 this. 0. Okay, this for I in length of p. Okay, fine. This one list compress should work. I think I'm doing something. I will check it later. Anyway, this should be fine for us. This I'll come back to this later. Check this later. Okay, this is anyway. If you want to do this way, this is also fine. If you want to this way, this is also fine. If you use list compression, that is also fine. But this is since Python provides, I think I would go for this one. So, and then I know for the first one, we know the result already, right? Result of 0th element is always 1. It can't go beyond that one. So now what I need to do, I need to traverse from year to year, correct, right? So I'll do for I in range operation. This one I'll use because I need to get the index. I need to start from 1 and I need to end at this point, right? Length of input. Just I'll do print I 1 2 3 4, or I'll just do input of I'll print 80 60 because I want to find out for this cell up to 85, correct, right? If I do this loop, at least I'm traversing all the elements once. So but when my j is at year, okay, I is at year, right? What I need to do, I need to traverse from year to year. So for j in range, what is the starting point? Starting point is I. What is the end point? End point should be 0. But if I do 0, the year length is actually, if you look at it, 1 2 3 4 5 6 7. I'm doing length 7, but since it uses index 0 to 6, it has to do, right? So that means it is coming from 0 to 6. But if I do 1 to 0, it will traverse only once. It will not come 0. Because 0 will be it's excluding the end point. That is what the syntax is. So endpoint, my endpoint, I need 0. That means I need to go 0 minus 1, which is a minus 1, so that it will traverse from 1 to 0. Basically, if I look at the index 1 to 0, both it will traverse. It has to traverse. So and then I need to go left hand side, right? So I need to decrement by minus 1. Because even if you look at it, it's as good as this one. 1 is the starting, this is the end point, and how many steps I need to increment? 1. Here I need to, since I need to go on the left hand side, I need to decrement by 1. So here This is the I is pointing at here, and then now j also pointing at here. Just I'll reduce this. I is pointing at here, j is also pointing at here. So now if it is equal also, then it can bypass, right? So what I need to do, if input of I is greater than or equal to input of j, okay, I can bypass it, right? So what I need to do, I need to find out answer for I, because I is the outer loop, right? Result of I is equal to result of I plus 1. Correct, right? So now what I need to do, I did that. Then else I'm not doing anything at this minute. If not required, we'll remove. Then I update it with 1. Now what I need to do, I need j will go at this point, right? J will come at this point. But 100 is blocker. I mean 100 will block. But if 100 blocks, for example, I don't have to go left hand side, right? For this one, it is no problem. I solved it. So now let's talk for j. When it goes to the outer for loop, then I is pointing at third element, which is 60. So and then j is also, I'll start from this guy. Input of I, that means 60, is greater than input of j. 60 is greater than 60. So I get the result. That means initially it will be 0. I'll increment 0 to 1 output, and then I decrement j minus 1. Then 80 is greater than 60. That means input of I, 60, is not greater than or equal to 80. So it comes in the else part. Do we really calculate for 100? No point, right? This guy itself will block. No way signal can bypass 80. So here, instead of doing pass, just come out of the loop. Okay, come out of this inner for loop and then increment j and then reset j back to I and then do it. So now I and j are at 70. 70 is greater than or equal to 70. So decrement I comes at this point. I is still greater than 60. So j comes at this point. Then 80 is the blocker one. Don't go beyond left hand side. Stop it. Then reset I to 60. Then reset back j to 60. Keep doing it. Then we'll get the answer. So let's comment these indexes. Then let's run. So if you look at it, 1112146. 1112146. Correct, right? The answer is right. Let's try giving some another input. If I do 100, 90, 80, for 100 also 1, 90 also answer should be 1, 80 also answer should be 1, because it cannot block. Sorry, it cannot bypass. So 1, 1, 1. But here if I give 200, it can bypass all the units, right? This 1, 2, 3, 4. Answer should be 1, 1, 1, and 4. If you look at 1, 1, 1, and 4. But what is the problem with this approach? The problem is for each element, we have to traverse the entire array. That is the problem. So complexity would be time complexity is O of n square, which is not really acceptable. I mean, but there is a room for improvement. It's not like it's not acceptable. There is a room for improvement. Then I'll remove some, prints. Just it will be weird. So here just I'm printing. If you want to return, you can just return result. Okay, and then here just you can print here 1, 1, 1, 4. Is it clear? The brute force method. Any questions? But because we all know how stack works, right? But the thing here, the tricky thing is, can we leverage the stack here? See, whatever the stack we created, by leveraging this, can we bring the complexity down from O of n square to O of n log n or O of n up to O of n? Any thoughts? clear at least up to this point? What problem statement and the solution?
Yeah, it's clear with respect to the brute force and
Yeah, go ahead.
yeah, a clear till brute force. I'm just
Oh, okay. Yeah. See, let's see. Can we leverage the stack? Right. Let's draw some whiteboard thing. Okay. See now, right? Okay, let's see. Can we again? What these are all the elements, right? These are all the elements, and assume this is my stack. Goes from this side. First, if there are no elements in the stack, I cannot do any computation. Let's push whatever the element. If a stack is empty, just push 100. I pushed, and I'm pushing index also. You'll come to know why I'm pushing index. Correct, right? I pushed 100. So 80, okay, and then for 100 while pushing it, just this is the leftmost element, right? So what is the answer? See, I is equal to 0. Let's not come to the answer, just we'll do some sampling. See, I is equal to 0. I pushed 100 to 0. Then I is equal to 1. Correct, right? But 80 is 80 is the bigger one. If it is bigger than the element present in the stack, that can bypass, right? Correct, no? But if 80 is smaller, it cannot bypass. It cannot bypass the signal because 100 will be the blocker. So I is equal to 1, and then I'll push 80 also. 80, and then what is the index? Index is 1. Then 60 is also, 80 is the blocker. 60 cannot, what do you say? What do you call it? 60 cannot bypass 80. So 60 also I'll push to the stack. 1, 2. 70, but 70 can easily bypass 60, right? Because 60 is smaller than 70. 70 is point. So what I'll do is I'll remove 60. Whatever the element smaller than the current element, I'll remove. I'll pop. So 60 is smaller. I'll pop. 70. And then 70, 80 is the blocker one, right? Because how many ways it can reach from year to year? What is the value of I? Index 0, 1, 2, 3. What is the index of j? That means which is the top element? 1. Current is 3. If I do 3 minus 1, I'll get 2, right? 3 minus 1, 2. It can traverse 2 elements. This is the one, and from year to year. Correct, no? Somewhere we are getting some formula here. Then 80 is the blocker. I can't do anything. Push 70 back to the stack. 70 I pushed. What is the index? 3. Then 60. 60 cannot go beyond 70. So I'll push 70, 60 also. 60, and then what is the index? 4. Then 75. 75, 60 easily I can bypass. So I'll pop 75. What is the index? 4, 5, 6. Index is 5, right? And then 70 also lesser than 75. So I'll delete it 7, pop 70 also. But 80, I cannot bypass 80 because 80 is the bigger one. What is the index of current element? 75, which is 5. What is the index of topmost element, which is 1? Can I subtract 5 with 1? 5 minus 1 can I do? If I do 5 minus 1, 4. If you look at the number of elements it traverses from all the way from year to all the way year. 1, 2, 3, 4. We got the answer 4 here. So then 80 is the blocker. I can't go beyond 80. So 75 is the currently I'm processing. So I'll push 75 back to the stack. 75. And then what is the index? 5. Right? So then 85. 85 is, I have to find out an answer for 85. 75, right? So 85 is bigger than 75. I'll pop this. Then what is the next element present in the stack? These are all already popped. Next element is 80, right? 80 is also lesser than 85, so I pop this. But 85 is bigger, not less, bigger than 100, so 80 will block. So what is the index of top element? 0. And what is the index of current element? 6. If I do 6 minus 0, that means 6 elements I can have. 1 2 3 4 5 6. I got an answer. Then all the processing is done. Correct. But the yeah, that's the answer. But we'll try out with various different inputs so that we can come to the conclusion whether we can generalize the problem or not. So this I'll keep it as it is, and I'll write the pseudo code first. What happened? Hello, you can hear me, right?
Yeah, we can.
Yes. So okay. Since the page did not load, I thought I lost connectivity. Say, let's take 80, 85, 75, 65, and then 100. Correct, right? So I'll write the bar graph so that it will be easy to visualize. 85. This is 80, 85. This is somewhere 75 is here. And then 65 is here. Then it is 100 above. Index is 0, 1, 2, 3, 4. There was a noise, so I muted. Okay, now what I need to do, I need to start from this, right? What I'll do, I'll just create the same thing, output array or result array. I'll initialize everybody to 0, 0, 0, 0, 0, 5 elements, right? 0, 1, 2, 3. Now what I'll do is, first I'll, whether my stack is, okay, first let's trace. This is, my stack is empty, right? That means I cannot pop. I can pop only if stack is not empty, right? And so if stack is empty, I need to do for this guy, right? What is the answer expected and what is the I? I is 0. What is the answer? And it can traverse only one, right? That means to get 0, what I need to do? I need to do 0 plus 1. Say if stack is empty, what I'm doing is output of I is equal to I plus 1. Just I'm doing, since it is 0, if I do 0 plus 1, it will work, right? So let's take, for that matter, 1 second. I'll take this one, 100, 80, 60, then 120. 100, 80, 60, 120. 180, 60, 120. 0, 1, 2, 3. Y is equal to 0. I can push only one element, right? So all the answer is 0, 0, 0, 0, 4. Okay. What is the I is equal to 0? If stack is empty, if I do I is equal to I plus 1, I'm getting it, at least for the first value. So output of I is equal to I plus 1. Then I got 1. Then what I'll do, I'll push 100 and 0 is the index. Then 80. 80 is not, okay, if I, okay, yeah. Then I wanted to tell some, okay, let's say else. 80 is not, 100 is the blocker, right? For this 80. So if I subtract one, if I do 1 minus 0, because this guy is the blocker, so this is the source and this is the destination. If I do source minus destination, only those many units I can traverse, correct, right? So if I do output of I is equal to what is that I minus what is the top elements in the set, 0, right? So if I do 1 minus 0, it is 1. So this is also 1, and then I'll push 80 and 1, and then 60 also stack is not empty, and 60 is not greater than 80. I cannot do any pop operation also. So then it comes in the else. If I do, I need, this will be the source and this will be the destination. If I do 2 minus 1, only those many units I can traverse. So it is again output of I is equal to source minus destination 1. Then I'll push 60 to the stack. What is the index? Index is equal to 2. So now current element is 120, but 120 is bigger than 60. I mean, it is the current top element. So what should I do? I need to pop 60. I need to pop, even 120 is bigger than 80 and 120 is bigger than all these elements. So essentially I should pop all the elements from stack, right? So since I have to do it in a loop, let's do it in while. While stack not empty and what is that, input of I is greater than or equal to top element. What I need to do, just do pop. So 60 is less than 120, I did pop. Then 80 is less than current element, I did pop. And then 100 is less than 120, I did pop. So this, then again it goes to the while loop. Since stack is not empty, but since stack is empty, it will not enter into the while loop. So it comes here. If stack is empty, what I need to do? I is equal to, what is the current I? 0, 1, 2, 3. I is, if stack is empty, can I do I plus 1? That means 3 plus 1, 4. That means all the way it goes from here to here, right? I plus 1. It's satisfied for this condition also. It's satisfied for the very beginning element also. So that means we can generalize this. Probably we can take one more example and then see whether it works or not. Is it clear?
Yeah.
Yeah. Shall we jump into the coding, or you want me to take one more example and explain?
I would say we can jump, I think.
Okay, fine. Yeah. Yeah. Where is the one more tab? Find these other things. Okay, or else we can complete this. I did not do, right? I jumped this one. So again, 80 is the first element I pushed into the stack, 80 and 0. Then 85 is greater than 80. So I need to pop. And then after popping, see 80 I popped in the while loop, right? Somewhere here. And then again stack is empty. So if I is equal to 1, and can I do O of I is equal to I plus 1? Yes, right? Because it has to traverse 2 elements from here to here. So that means we can easily generalize this. Then I pushed 85 and then 1 index, but 75 is not the bigger than 85. So I'll push 75 and 2. But since it is a bigger one, I need to do source minus destination, 2 minus 1. So then I'll get what the result, those many units it can, bypass. Then 65, while pushing only, probably we can, easily find out the answer for all of them. Only if, before pushing. Or if the current element is taller than the element present in the stack, just keep popping it. That is the, the core logic. Let's try here. Anyway, stack is ready. Then, sorry. Def signal range, then stack based approach, right? I'll call it as input. Same thing. See this, anyway, I'll take it. Okay. Now what we should do, if stack is not empty, right? Okay, I need to create a stack object, right? My stack is equal to stack. See, I'll not go with the capacity here because I want I don't want to restrict it to 5 or 6 elements. I'll remove the capacity one, and index also not required. This I'll remove, not required. This is just, I'll keep appending it. Okay. This is not required. Correct, right? Only stack full in the push, nowhere else. Okay. My stack object, then okay, what I'll do, I is equal to 0, then I need to traverse all the array at least once. I is less than length of input. Correct, right? Just I'll do no errors. Okay, so now if stack is not empty and if the current element is bigger than the stack top element, we need to keep pop the elements, right? So while my stack dot is empty equal to false, or current element, what is the current element? Input of I is greater than or equal to top of the stack element, right? My stack dot top. Okay, then what I need to do, I need to,
Is empty should end with parentheses, right?
yeah, sorry, yeah, that's correct. Okay, and if it is top value, what I need to do, I need to do keep pop the things. My, see here, since I'm operating with all the indexes, I'll push only indexes. Value is not really required. If I get the index, and since I know the array, like if I do array of index, I'll get the value. So I'll push only the indexes. So my stack dot pop. Okay, and if my stack dot is empty equal to true, what I need to do, I need to put, anyway I need to push, but what is the, we did some kind of formulation, right? If it is empty, if I do I is equal to I plus 1, is to get the answer, correct, right? First I is equal to 0, it can go only one, I can bypass only the current element, right? So that means I is pointing to 0 plus 1 and get the answer. So to result of is equal to I1, else result of I is equal to I minus my stack dot top. Once this is done, what I need to do, I need to push the current element into the stack, right? So my stack dot push I. So now here print result. Anyway, since we already have the brute force method, we can check whether the current and brute force result of current method and the force element are same or not. Right, I'll just do it the same thing. In I'll call stack. Is that fine? Some errors. Okay, what is the errors? My stack empty or input of I is greater than something, syntax error. Length of input. Sorry, I need to increment, right? That is different thing. Why it is trace back is coming?
My ST.
Yeah. Okay.
If condition.
Yeah. Okay. My STK, my stack, right? Yeah. Here I need to do I plus 1, right? Or else it will go in infinite loop. So invalid syntax. Huh? Sorry, if is not there. Oh, oh man, okay, all indentation went wrong now. It is equal to true. Oh, result of I is equal to I plus 1. Else, okay, this one, yeah. Yeah, here I need to add that condition. Sorry, this is R. No, this is and input of current element. Current element is greater than or equal to input of my stack dot top element. I think it went in infinite loop, I guess. Yeah. 5822. Yeah. Okay. Correct, right? If stack is for not empty and current element is greater than or equal to the last by, this is the index, right? So this is the index. I'm just dereferencing it. Then I need to do. Oh man, sorry. This is my stack dot pop. Earlier indentation was correct. And this I do, or else you push. Yeah. See, this is the older result. Brute force. Brute force is this, and this is the stack based. Solution I'm printing here. Just I'll do return. Where is the answer? Oh. Brute force is 1114, and then stack based solution is also 1114. Let's change the input. Brute force is 1112146. 1112146. Here, so this is the friend square, but here we are doing it only one loop, and at max it can go up to 2n. Not, it's like n into n. This one, if I generalize that is a 2n. 2. So if I remove the constant, this the complexity would be O of n only. There is a drastic performance improvement from this solution to this solution.
Line number 82, the AND condition, the AND condition, if you can explain a bit.
Yeah, AND condition, right? Okay, this
after
is
AND,
yeah. This is what I'm doing here is, if you look at this thing, assume consider 70, 85 is in stack, 75 also in stack, 65 also in stack because it's in this order, right? And I'm processing I, the fourth element, I is equal to 4. That means if a array is this, right? If I do array of 4, I'll get 100 greater than or equal to what is the top element index is I'll get, if I do top element, I'll get the index because I'm storing index 3. I'm doing array of 3. Array of 3 is 65. Yes, it is greater, right? So I need to pop. Again, 100 will remain same. What is the top element? 2, which is array of 2. What is that? 75. Again, 100 is greater than 75. I do pop. Again, 85. What is the top element? 1. What is the array of 1? 85. 100 is greater than or equal to 85, which is true, right? I do top. That is the pop operation. Is it clear now?
Yeah. Stack dot top. Does that return the index or does it return the top item?
No. I'm pushing only index. If you check here, I'm pushing in I. Whatever I push, it returns that. But I'm pushing only index, not value. See, if you look at the implementation top, I'm returning the last element present in the stack.
Okay.
But here I'm pushing index, not the, yeah. Value is not really required. That's why I'm not pushing. Yeah, that's all for today's session. And
just a request, appreciate if you can ping the what is that? The problem statement.
Problem statement.
Yeah.
This I think I picked from Hacker or Thai.
Okay.
Where is that? Sorry. Anyway, I can send it to everybody. Or else I'll do one thing. Share your email IDs. I'll share all the problems and solutions.
You can for now. Just for now, I just wanted to, do it my own way.
Can you ping?
Yeah.
Ping. I'm not getting because chat.
Yeah, you can check. You can check the Zoom chat.
Your name? Your name? Hello? Hello?
Yeah, it's Samrat. SAMRAT. Samrat.
This okay. Fill the problem statement. Yeah, I think.
Thank you so much.
Yeah, that's all for today's one. And if you want to join full course, please contact Learnbay or you can contact me also.
Yeah. Thank you so much.
Yeah. Any questions from anybody?
So for course details, we can get in touch with Learnbay. That is what you said, no?
Yeah, you can. I mean, now also I can explain if you want what is the course, complete course content. I mean, we basically cover all the data structures, algorithms, and here if you're planning to, it depends on your this one interest. If your motive is to change the company and get the premier product companies, right? We have a set of complexity-wise programs, so we can take that as well. It covers all the way from stack to graph, advanced algorithms also.
Okay. So fee structure and those we need to, how can we know that?
It's around 24K, but I think it's some discounts are there. You can get in touch with Learnbay.
Okay.
Or you can call, you know the contact number, right?
Yes.
Or you want me to share?
No, that is there in the email, I think.
Yeah.
Yeah, thank you.
Yeah, thanks. Yeah, thanks guys. Bye.
Yeah, thank you so much. Have a good day.
Yeah, thanks.